So we're continuing the lecture on ability tests, specifically testing intelligence. And what we covered on Monday in class was broadly the history of creating theories of intelligence, and also looking at kind of the difficulty in defining what the construct of intelligence is. And we kind of left off on that the primary models that are used today are kind of hierarchical models, where the idea that there is a single construct, sometimes referred to as intelligence quotient, sometimes referred to as G, but it's made up of subcategories, larger categories, somewhere between 5 and 8, depending on the theory, such as verbal intelligence, quantitative or mathematical intelligence, visual spatial, memory, and other elements like that. But each one of them is then further made up of additional factors, such as how quickly you can do it, how quickly you learn. So, for example, if we're looking at just knowledge, for example, not only is there knowledge that you have, there's also the factors of how quickly you learn, how accurately you remember information, how quickly you can call up knowledge and integrate it. So anyway, we were moving on from there, though, to kind of just talk about some of the general issues in measuring intelligence. And one of the things we were talking about is there's kind of an assumption with any construct we're interested in measuring that there's a stability there. We've kind of talked before about the idea of trait versus state, and that most of the constructs we're interested in trying to measure in psychological tests and measurements are stable traits. So generally, the stability of intelligence is somewhat supported. As we were talking about in class, intelligence in adulthood does appear to be relatively stable. The highest predictor of lifetime intelligence tends to be young adult intelligence. So if you're actually wanting to predict how intelligent, how smart, how successful someone's going to be in their schools and in their education and in their careers, usually you do need to wait till kind of young adults. So again, ranging in middle school to high school. And that's been found to be the most important determinant of cognitive performance as an older adult. In other words, predicting how smart you're going to be throughout your life. Generally speaking, verbal intelligence skills tend to be highly stable over time, but newly learned information is much less stable. So again, it seems like that our language abilities, our verbal intellect, tends to form fairly well, tends to build slowly over time, and it's fairly stable. But when we're talking about actual knowledge, there's a lot more less stability. And you can kind of think about that when you freshly left a lecture, probably a lot of the information is available to you. But if you do not review that information, if you don't take a test on that information, very quickly, within days or weeks, a lot of that information is lost. And that's kind of what we're talking about, that though a part of intelligence is the knowledge that we learn, but our knowledge itself tends to be a little less stable over time. And we also know that that stability of intelligence does tend to decline. Many of our cognitive abilities tend to decline in later adulthood, especially beyond age 75. Another issue with measurement of intelligence is something referred to as the Flynn effect. And this is the progressive rise in intelligence test scores that's expected to occur on a normed intelligence test from the date when the test was first normed. So again, if we're talking about intelligence as a stable construct, and we're creating an intelligence test that is normed on a large sample, we'd assume then that that norm, and remember that norming is creating an interpretable score from a raw score. So for instance, an intelligence test might have 200 questions, and you get a point for each one right, so you could score between 0 and 200. But the norming process is then figuring out what is the average score in the population, and then converting that to, for example, an intelligence test, often a score of 100. Most intelligence tests are scored with the idea that an IQ of 100 is your average, and then your standard deviation is either 15 or 16, generally 15. So someone with 115 IQ is one standard deviation above the mean, higher than about 67% of people as far as they're intelligent. And someone with a 85 intelligence is one standard deviation below the mean, so only about 33% of people they're smarter than. So what happens with the Flynn effect, though, is that once we norm this information, if we keep using that test, as we go through generations, about every 25 years, we actually find that the raw scores are going up, which means that if we compare, so if we norm an intelligence test, let's say in 1950, the average score is going to be 100. If we use that same norm 25 years later, we're going to find that almost everyone's scoring closer to approximately 112 now. So those norms have to be changed. So what this appears like is that basically it seems like people are getting smarter. Let me walk through an actual example of how this kind of works. So we have a test in 1925, an intelligence test, that's measuring both fluid and crystalline intelligence. Again, fluid intelligence is that kind of raw, more genetic ability. Crystalline intelligence is more of what we learn, that nurture effect, so our environment, our schooling, our gathering of information. So we have our raw scores, and let's say that in 1925, the mean raw score was a 40, so this is converted to 100. On that, 100 is the mean, and then plus or minus 15 scale. Now, if we move forward a generation to 1950, we find that the raw score that people are now scoring on that intelligence test is a 50. It's up about 10 points, which means if we use the old norms from 1925, now people with a score of 100 are no longer the mean. The converted norm score of 100 is actually a very small number of the population. In other words, it looks like the population has gone up almost 15 points in intelligence. Now, if we keep giving this same intelligence test and keep using those 1925 norms, we see this problem continue to compound. So we have to move those norms up. If we leave them alone, the norms don't make sense anymore. So we have to re-norm the test because of the Flynn effect. In 1975, again, if we're looking at those 1925 norms, now 50 years old, the average raw score is now up to 60 on that test, which translates to, again, a norm score of 130. So by 1925 standards, the entire population is now on average 2 full standard deviations above the mean. So that means that the people taking the test in 1975 that are doing average on it, as far as the number of items they're getting correct on the raw score, are people that we would consider by the 1925 norms to be 2 full standard deviations above the mean, which means that we'd be assuming that they're in the top 95 percentiles. There's only about 5% of people that should be smarter than them. But in reality, they're actually just the mean. So again, we have to re-norm to get that 100 to the midpoint. And as we continue this forward into the year 2000, now, again, another generation, if we're using those 1925 norms, we're now finding that the average person scoring a raw score of 70 would be figured out by the norms of 1925 to be full 3 standard deviations above the mean. So less than 1% of the population would be smarter than that person, according to the norms used in 1925. This now indicates that person is highly above the mean, and again, in order to handle this problem, we have to renorm that test to once again make a raw score of 70 now equate to 100 on our norm scale. So there's been a lot of speculation of what's causing the Flynn effect. It's clear, most people agree, that it's not that people in the year 2000 are now drastically smarter in both fluid and crystalline intelligence. In fact, fluid intelligence is primarily hereditary, which means, genetically speaking, it's not a very good argument that in 3 generations that we have developed that much genetically, that we have evolved to where our intelligence is now almost 3 times as smart as we were 3 generations ago. What's most likely occurring is an effect of crystalline intelligence. And this is also a good illustration. The Flynn effect illustrates the importance of crystalline intelligence, especially to intelligence testing. So crystalline intelligence is affected by education. So one thing we know in the United States is that the education systems have been improving since 1925, 1950, 1975 to 2000. Different techniques have been used. There's been standardized testing, and there's some argument over how successful these programs have been. But there is no question that more people are getting more accuracy. If we look at literacy rates, we see that they've been increasing. The number of people graduating high school has been highly increasing. So we have a more educated group of people. Also, crystalline intelligence is strongly affected by environment. If we look at poverty, we find that less people are living in poverty, and what it means to live in poverty is different from 1925 to 1950 to 1970 to 2000. We also look at technological advantages. Again, the ability to get information. from 1925 to 1950 to 1975 to 2000. The growth of TV, the growth of radio, the growth of the internet. All of these have provided additional resources for people to be able to gather more knowledge. Additionally, more and more people have been going to college, and more people have been getting advanced degrees as we go from 25 to 1950 to 1975 to 2000. So the Flynn effect is most likely being driven by an increase in crystalline or knowledge-based intelligence. Also, environment effects as far as health. So the healthier you are, the more likely you are able to function at a higher level, the more likely you are to gather more knowledge. And again, we also can see trends from 1925 to 2000 of increased health care and increased access to health. What's also further supporting this is the Flynn effect has been found not just in the United States, it's been found throughout the world, but generally it's strongest in developing countries. So countries that are in the process of increasing their education, increasing their access to information, increasing their access to health care, that's where we find the largest Flynn effect. And actually, recent studies of the Flynn effect in the United States have found that it's been leveling off. It's still there, but it's much smaller gains from generation to generation. So some additional issues when measuring intelligence. And these are issues that in every case, the question is, should we be measuring this or should we be adjusting for it? So there are some gender differences in overall average scores in intelligence tests. Males across the board, on average, tend to outperform females in tasks requiring visual spatial recognition. So basically, any of the tasks that require mental rotation, pattern recognition, what's the next symbol, men on average tend to slightly, and I really want to stress slightly, outperform females in these kind of tasks and intelligence tests. While females tend to excel at language-related tasks. So basically vocabulary, understanding a passage, drawing inferences from language or written passages. Women tend to, again, it says excel here, it is a difference on average. Women in general are better than men in general on these kinds of intelligence tests. Excuse me. But again, it's a relatively small effect, and the difference has been getting less and less as more men and women are actually being exposed to more education and more, well, again, crystalline intelligence, that knowledge-based acquisition. Some studies have actually challenged these gender differences and say that they are almost completely based on experiences. So, for instance, if you actually take men that have never actually played with, like, building blocks or Legos, and then test them on visual spatial recognition, you often find that they score very similar to women. And if you take women that actually, as children, mainly played with engineering toys, blocks, and Legos, they actually tend to score similar to men. So that's, again, some evidence that kind of suggests this isn't necessarily a difference in fluid intelligence. It's a difference in crystalline or nurture-based intelligence. But again, if we're using an intelligence test to make determinations of who's going to get into college, who's going to go on to get into graduate school, and also for job selection, all of those we may want to ask, is there some gender bias? Are we using a test that may result in a disproportionate number of men for spatial visual tasks or a disproportionate number of women for language-based tasks to be getting those jobs? There isn't necessarily an answer to this question. It's something to consider. And a lot of people that use these kind of tests do want to ask themselves, what are the consequences legally? So gender is a protected class in the United States for the purposes of hiring and selection. But also, do you want to use a test that's highly predictive? And in most cases, we tend to try to make sure that we lessen the effects of gender in our intelligence tests, but still use them knowing there may be a little bit of bias. Most intelligence tests definitely capture somewhat of family environment. Children thrive in a loving home where their safety and welfare are of the utmost concern, and learning and growth are promoted. So again, we go back to that model we were talking about on Monday, that we do have apparently a fluid intelligent kind of range. So there is a genetic component that basically indicates kind of the range of how low you could sink in a bad environment and how high you could thrive in a good environment. But that range is pretty large, and that's why for example, the Flynn effect illustrates how easily that range can be affected by the environment. So when we're measuring intelligence, if what we're trying to claim is we're truly measuring an innate thing about the person themselves, their actual raw ability to learn, we're often capturing also a fair amount of that crystalline intelligence, their experiences, their nurturing, their knowledge. So again, we have to ask, are we wanting to try to completely remove that as much as possible? Are we wanting to look at that as error that we don't want to capture in the test? Or are we okay with accepting the fact that we are going to be, again, selecting for people that may not necessarily be genetically or physically the smartest people, but the people that have had the best experiences? As I kind of mentioned in class, when we actually look at predicting intelligence, some big predictors include the presence of resources such as books in the home, the parents' use of language, so reading to your kids, talking, using large vocabulary, parental expression of concerns about their kids achieving, and also an authoritative parenting style. So basically, there's authoritative, there's permissive, and there's authoritative. So authoritarian parents are basically very dictatorial. Do what I say. Children should be seen and not heard from. Permissive style is basically let kids just thrive, let kids just alone, and they'll just naturally progress. An authoritative style is a style that both provides love and support, but also provides some boundaries, rules, and expectations. And that particular style also is highly predictive of basically children thriving and becoming more successful in their development, if you will, of intelligence. One of the more larger issues that is often discussed, both culturally but also legally and within the research, is cultural differences in intelligence tests. So culture provides specific models for thinking, acting, and feeling, enabling people to survive both physically and socially and to master the world around them. So all of us have various cultures that we're a part of. Being a citizen of the United States of America makes you a part of the culture of the United States, but also your family and its background. For example, my family's German, and there's some things that we do that are kind of leftovers from that German culture. So that's another part of my cultural experience. I came from a fairly stable family with a mother and a father that were relatively happy with each other and stayed together the entire time I was raised. And I had a fairly large family, 2 sisters and a brother. That's kind of a cultural background that I have of just the family unit that I came from. Also, what state you come from, your ethnicity, gender, all of these provide kind of cultural models of your thinking and acting. So when someone designs a test, it is very hard for them to remove themselves from their own culture. So most tests have some form of culture loading. And we'll talk about that a little bit in the slide, but culture loading at the bottom here is the extent to which a test incorporates vocabulary, concepts, traditions, knowledge, and feelings associated with a particular culture. So to create an intelligence test, we have to come up with questions that have right and wrong answers. We have to have a way to discriminate whether someone has a low level, a mid level, or a high level of intelligence through testing. As we're designing those questions, we have to ask ourselves, is the person designing the questions using vocabulary that is comfortable for them, but is not necessarily going to be comfortable for everyone? And then we have to ask, does that use of language actually bias the test? Kind of a ridiculous example is you can think of someone that has been raised in a very high social economic status might write a word problem test with an example of Tiffany goes to Saks on Fifth Avenue in her limousine. She passes 3 gazebos on the way and then stops off to have a spritzer. Now, how long will it take her to get to Saks on Fifth Avenue? Now, there's no real answer to that question. I'm just making that up off the top of my head. But that's a pretty culturally loaded question. There's some words in there some people might recognize. It's definitely talking about an experience that a lot of people wouldn't have. So when we're talking about culture loading, we're talking about probably not something that overt, but we are talking about looking for the questions and asking, are these somewhat loaded to where some people within a specific culture will be more likely to understand and empathize with the question because they'll probably do better on the question. So back up to the second point, items on an intelligence test tend to reflect the culture of the society where the test is employed, and thus many theorists have expressed a desire to develop what's called a cultural free test. The idea of a cultural free test is that basically, ideally, a cultural free test would have no cultural learning. It would measure intelligence the same with any subgroup in any culture. So you could take that test and use it for rich people in New York City, but you could also go to a small tribal region in Kenya, South Africa, and use it equally as well, and both groups would actually find nothing of any kind of culture loading in that test. Most of the efforts to make culture-free tests have been very nonverbal, very visual tests, but even the symbols we use are sometimes culturally loaded. They're symbols that make sense in one culture but may not be used in another. Even color is interpreted differently. So when we look at snow, we probably see it as white, and we say, that's white snow. If you move up to Alaska and look at the Inuit people, they actually have literally over 100 different shades of white they recognize in snow, and names for those kinds of colors in snow. And again, that's an example of, even if you're just using a color comparison as a measure of intelligence, there's still going to be cultural bias on it. So the environments we live do somewhat not necessarily change how we perceive the world visually, physically, but how we actually label it and think of it is being changed by culture. So generally speaking, what most organizations are now working on is developing basically culturally fair tests. And the idea here is to try to reduce the culture loading, so make the questions as culture-free as possible, but still then recognize the limitations of that test. So for instance, you might make a culturally fair test for rural middle school students and within the United States. So this is again kind of knowing what the test has been created for and knowing who it's been normed off of. And that gives you a better idea. But you also wouldn't want to use that same test then, for example, for immigrant children coming in from Russia. So most modern ability tests are individually administered. There are tests that are available for mass use. The SAT, the ACT, the GRE are all examples of that. But also notice that when we were talking about our modern theories of intelligence, we were talking about a hierarchical model. We were talking about a model where you have an overall construct, G or IQ, but then you have multiple constructs, usually 5 or more, and then even further constructs under that. Most of that kind of advanced modeling of intelligence are lost in the tests that are given out in mass groups. The GRE, the SAT, the ACT often will have one overall score and maybe 2 or 3 subcategories. So the advantages of an individually administered test is, one, these tests are usually longer. They're usually more based on theory. They're usually better at getting at these subcontracts. Also, more methods of assessment can be used. So when it's individually administered, you don't have to rely on just a computer-based kind of multiple choice or fill-in-the-blank test format. You can actually have people do physical tasks, visual perception tasks. You can have people actually interact with objects to kind of get an idea of how they actually can apply their intelligence to the real world. Additionally, the person taking the test has the undivided attention of the administrator, so there's actually an additional value to this. And mainly that is rapport building. So the person giving the test can reassure the person about how the test is to be taken. If there's any questions about instructions, they can be answered. And generally speaking, the person can also then adjust the test based on age, gender, ethnicity, and social class, and even language skills. So being able to interpret the test questions for just what does this word mean when the word isn't necessarily what's being defined, it's just a part of the question. All of these adjustments really are hard to do when you have a standardized test that everyone's taking. Now, the disadvantages, it tends to be more time consuming. The administrator must have very specific qualifications to give the test. It requires a fair amount of training, often certification. And you also must be very familiar with that specific test given. So the payoff here is that when you use an individually administered test that has someone that's been well trained and rated on that test and familiar, we usually find it's a little bit easier to make it culturally fair because you have someone that can actually adjust the test slightly as needed to kind of adjust for some of the issues that we were talking about as far as measuring intelligence. But we also can use more methods to get a better, more holistic view of the construct of intelligence as we understand it from the models that we've talked about previously. So the first test we're going to talk about is that original test, the Stanford-Binet. So created by Binet and Simon in 1905. If you'll remember, this was specifically designed to test the performance of school-age children in France. So it was the first test to successfully predict scholastic performance. So there had been attempts to make an intelligence test prior to the Stanford-Binet, and at this point called the Binet-Simon. But this was the first one that actually highly correlated with actual performance in schools. Now, we talked a little bit about how this is also a lesson in that idea of culturally norming a test or worrying about culturally fairness, because that test was then used by a lot of different people in settings it wasn't intended to. There was multiple revisions. The third revision of the Binet-Simon was in 1911, and it had 54 subset tests categorized by age group. And it was designed now for ages 3 to 15 and adults. So there was subtests, different types of constructs being measured by the Binet-Simon. So trying to basically get at education, but also fluid intelligence, though it wasn't called that at the time. But there was also specific tests dependent on your age. So we now have a fairly large intelligence test that's made to capture different age categories. In 1916 is the first actual Stanford-Binet. So Simon's out of the picture, and Binet is kind of taken a back seat, and now Stanford is actually revising the test. It was published by Lewis Terman at Stanford University, so that's where the Stanford-Binet comes in. And Stanford, the university, has now been pretty much the center point for the continued development of this test. It added more fluid items, so more items that actually got at kind of hereditary or genetic intelligence. So it was now measuring both knowledge or crystalline intelligence and fluid intelligence. And this is also the first test that brought up the idea of a normed set of scales, an intelligence quotient or IQ. So the current Stanford-Binet is in its 5th edition and is still used to this day. And the Stanford-Binet is made to adjust for mental age. So your raw score is actually your mental age score, which is then divided by your chronological age times 100. And that mental age itself is also a normed score off of your raw performance on the test. Using your ratio IQ, this actually gives you, again, your IQ on 100 is approximately the average, plus or minus 15. So the Stanford-Binet Intelligence Scale 5th edition is also a full score can be converted into nominal categories designed by cutoff boundaries for quick reference. So here's the current scoring for the Stanford-Binet. Again, 90 to 109 is considered average, and that 100 point is our mean, our midpoint. 110 to 119 is considered high average, 120 to 129 superior, 130 to 144 is gifted or very advanced. And again, remember, if our standard deviation is 15 and our mean is 100, that 144 is approximately 3 standard deviations above the mean. So 3 standard deviations above the mean, that means basically the top 1%. And then 145 to 160, so even further above that, 4 standard deviations is considered very gifted or highly advanced. And going downward, we also see similar kind of scores. So 80 to 89 is about 1 standard deviation below. So you're smarter than about 33%, but you're definitely below the mean. That's considered low average. 70 to 75 is borderline impaired or delayed. 55 to 69 is mildly impaired or delayed. And 40 to 54 is considered moderately impaired or delayed development. And generally, a lot of various organizations have kind of set limits on IQ. For example, the U.S. military has generally held 1 standard deviation below the mean as the average that they're adjusting for. Now, they're not using the Stanford-Binet. They use a series of their own tests. But if you convert the scores, their cutoff is approximately 85. So 1 standard deviation below the mean is about as low as they'll go and consider someone for military service.